And we are live to the world out there. Excellent. If anyone wants to help share the video for people that can't attend, I'm going to drop a link to that right in the chat. I'm also going to drop a link to the slides that I'm going to be using. There are links in these slides. Check them out. It'll make following up on things a whole lot easier. Second here. All right, and I'm going to get things going. So we'll typically get a couple more people coming in over the next couple minutes, but I want to get right into the meat of things. So with that, I would like to welcome everyone to our CleanTech Meetup. We're going to be focusing on recycling clean technologies. First, I want to thank our sponsors, Sac State Computer Engineering, College of Engineering and Computer Science. They had their D3 event today where we saw a lot of interesting topics being discussed and a lot of the cool research they've done, along with talking about how there's a lot of opportunities to collaborate and grow research into some really cool activities, whether it's more research or technologies that can benefit everyone. Additionally, I want to thank SMUD, Weintraub Tobin, Blue Tech Valley, and Moss Adams for being sponsors of our CleanTech Meetups. Also, who else is a sponsor? It's all of you out there. I want to thank the people who have donated to our CleanStart perspectives. And I want to encourage people right now to be on mute if they're not. So I want to thank everyone who has donated and has donated this year. Soraya, if you could drop a link if there's anyone else who wants to support CleanStart and the work we do, we very much appreciate it. Additionally, if you want to be able to connect with some of the resources that I've mentioned, a great resource is Sac State. The Engineering and Computer Science Department has Assistant Dean Jawa and Assistant Dean Shafizada, who work with connecting students and faculty with projects. And if you were looking for a good hub to connect with, Cameron Law of the Carlson Center, he's the executive director there. He brings together a lot of resources to support the growth of companies. Now with that, I'm going to outline tonight's activities. We are going to have some quick announcements followed by panelist presentations and the panel. Our quick announcements: make sure that you connect with us on social media. That way you can stay on top of it and make sure you know what's going on. Additionally, CalSeed, CalTestBed, CleanTech to Market, Rocket Fund, and CleanTech Open, they're all launching their 2021 programs. These are programs that provide funding, mentorships, and acceleration to clean tech companies. Also, all the speakers here, and I'll let them tell you more about what they're doing, all of them are working on projects that involve multiple stakeholders. So make sure that you go in there and connect with them. And if they have his newsletter, sign up with it and follow them on social media. Additionally, we have our CleanStart perspectives that happen about once a week. CleanTech Open is talking with us next week, and the following week or following 2 weeks after that, we have the Carlson Center coming to discuss. And if you really like the circular economy, we've scheduled Shira Lane of Up Kindness to talk with us later in the month. And with that, welcome to Recycling Clean Tech. This was really born out of kind of me discovering something that I feel like everyone here is probably like, oh, you didn't know that, Thomas? And that is that even though clean tech reduces emissions and provides a lot of environmental businesses, there still is waste. There's still end-of-life concerns that need to be considered. And if we don't consider them, they have negative externalities. So without further ado, I'm going to welcome Heidi Sanborn, Executive Director of the National Stewardship Action Council, and Jordan Wells, Assistant Director of the National Steward Action Council, Paul Gao, President and CEO of California Electronic Asset Recovery, and Sam Vanderhoof, CEO of Recycle PV Solar. All of them will be talking tonight, and then we'll have a panel afterwards. And we're going to start off with Heidi Sanborn and Jessica Wells. If you guys want to go ahead and share your screen.
Jordan will go ahead and share our screen. Thank you so much, Thomas, for having us and for cooking up this great idea for a panel. Again, my name's Heidi Sanborn. I'm the Executive Director, Founding Director of the National Stewardship Action Council. I've been working in the world of waste management for 30 years, based here in Sacramento. And I've been really evolved to the place where I really believe we've got to drive a circular economy. And I kept seeing a lot of stuff that, was coming at us, green tech, but I realized it was only green for what it was doing. We weren't finding a home or figuring out a circular way to use that material at end of life. So I'm really excited about talking about that tonight. And then Jordan Wells, who's our assistant director, she will be here at the end. I'm going to have to leave to be at the Child Abuse Prevention Council event. You might recognize I'm also a SMUD board member. So I am a utility geek or a policy wonk, waste, youth, energy, the whole thing. And so that's one of my SMUD activities. So I'll be leaving at 6:30 and Jordan can answer questions after that. But I am very glad to also be here with Paul and Sam, because both of them are real leaders in our area in clean tech recycling. And we need to do what we can to help support them and make sure people know about them and send more materials to them. So go ahead and my vision at the National Stewardship Action Council is that we attain a circular economy in the United States. So that's actually what I'm working on day in and day out. We are a 501c4 nonprofit. We had an office in Midtown. We let that go in December because we haven't been able to work there for months. So we decided that Jordan and I would just work from home. We've got a 14-member board, and it's very diverse, by the way, so we're very proud of that. And it's of businesses, nonprofits, governments, et cetera. And we're all working to drive to a circular economy, and doing that through collaborations and education. You doing presentations like this is a big, way we do that. And you can see our board at a strategic planning meeting a few years ago. So a lot of people ask, what is a circular economy? And we follow the Ellen MacArthur Foundation's definition, which is, basically, we can't do the make, take, waste anymore. We're pushing 7-8 billion people on this planet. And if that's our model, we're just fouling our nest. And we cannot, even animals don't do that. We have to really start closing the loop on this stuff and get back to Mother Nature, where everything, every waste material is a feedstock for the next system. So there is no waste. It's the ultimate zero waste system in nature. But we have interrupted that, and we have created products and materials that nature does not understand. And it's pollution when it gets out there. So we need to go back to a cradle to cradle approach, and really at the point of design, be thinking about how is this material going to be, made durable or repairable or recyclable, and make sure it's got an end of life besides a hole in the ground or a burn plant. That's just not sustainable at all. So we need to actually do three things in a circular economy. We need to design out waste and pollution, keep the products and materials in use, but at the very core of it too, we now have to go back and regenerate natural systems that we have dramatically harmed. And that's where a lot of people forget that piece. But doing less bad is not good enough anymore. We've done too much damage. So it's one thing to make sure we're ending the bad, but we've got to go back and repair the damage we've done. Next slide, please. So that means we have to think a lot differently. A lot of this has been driven from our flow of money and the fact that companies profit by externalizing costs onto the environment and others. And that is simply a model that is destroying the environment. It's not going to work long term. We have to change. So I always say insanity is doing the same thing over and over and expecting a different result. And being less bad is not, it's the same thinking. We have to do good and get to regenerative systems. Next slide, please. So one of the things that we've been really leaning into for many years, I spent a lot of energy fighting with companies and industries that didn't want to green up, didn't want to recycle, didn't want to pay for it, wanted to keep externalizing the costs onto the environment and local governments and others. And that isn't very fun. It takes a ton of energy, and it's more of a battle instead of a partnership. And the good news is the momentum is now behind us on getting to a circular economy. The public realizes we've got to do something. We've got way too much plastic pollution, and we're exporting waste to countries that can't handle it. And people are now realizing we've got to start managing our own material at home and keep the jobs here. And so I was very excited that one of the legislative bills we passed in 2017 actually on carpet recycling inspired a company called Aquafill to site a plant in Woodland called, it is Aquafill. And what they do is it's a zero emissions plant. They have about 50 people working out there, and it's a closed loop system for nylon 6. If you have fishing nets made of nylon 6 or carpet or anything, any widget made out of fabric, made out of nylon 6, they can put it through that plant and come out with beautiful, pure pellets of nylon 6 that are the feedstock for Stella McCartney handbags, Kelly Slater surfwear, interface carpet, and more. It's a wonderful circular economy model. And the biggest problem they have now is they can't get enough feedstock. So if any of you know of any manufacturer or any large company that has a lot of material that's got nylon 6, please let us know and let's get it over to that Woodland plant so they can recycle it. That's a picture of me with the CEO of the company on the left, Giulio Bonazzi, at their plant in Slovenia, and Franco Rossi on the right. And that is literally a picture at their plant where they store all the plastic fishing nets and things that they actually are paying indigenous people to pull out of the sea. Many of them have overfished and they need to go get those ghost nets out of the ocean, and they will pay them for them to go back to the plant and recycle them. And they just use steam and heat. They don't use any chemicals in that plant. So we're excited to have it here in California. Next slide, please. So that's a partnership we're proud of. Kind of businesses we're trying to bring to this area include aero aggregates. We've actually already had conversations with the governor's office of business, and we're very excited that they are looking at putting a plant here in Northern California, hopefully in this area, but it might also be in Stockton. We're not sure yet. But what they do is take mixed glass that is multicolored, could be contaminated, stuff that normally in the recycling system is very low value and isn't something we'd use. And they add a foaming agent, which is basically just a mineral, and they heat it and they make rock. And the rock is 85% lighter than quarried aggregate. And the reason that's very, very important is with climate change and sea rise, we are seeing more and more roads inundated that need to be elevated, and buildings need to be elevated. So this kind of rock that's much, much lighter and has no contaminants in it that would pollute the soil are perfect for elevating roads and buildings. And the problem we have now is, what is Caltrans doing and others? They're actually putting giant blocks of styrofoam under these roads, and styrofoam melts when gasoline and petroleum products hit it. So you have almost guaranteed pollution. So we should not be putting polystyrene in the soil, and this is a very safe alternative to that. So hopefully we can get that kind of technology here in Northern California. So I'm working on that right now in partnership with Aero Aggregates. Next slide, please. Another company we're working with is Bioenergy DevCo. They actually are an anaerobic digestion facility company that wants to site 220 plants all over the United States. They are out of Italy and Europe, and they are well seasoned, well financed, and we are talking to them every few days about trying to get them in Michigan, in Texas, because we've got a lot of organic materials that need a home. If they go into a landfill where it's void of oxygen, what happens? It gets to be methane. And then methane, even with the best capture system at landfills, a lot of it still is released. It's one of the top 3 generators of methane in California, is our many landfills. We've got to get the organics out of the landfills and into facilities like this where we can create biofuels that can be used for all kinds of purposes. So this is exciting, and we are also looking at trying to get them here in California, one north and one south. Next slide, please. And I'm also chairing the statewide recycling commission. There's 17 of us. Waste management is on there, LA County. It's a big group. They elected me chair. We were seated last June, and tasked with pretty much solving every waste problem that there is. And we're all volunteers. But we came up with 19 recommendations in 6 months with 17-0 votes, pure consensus, which is very difficult to do all the time in our industry. And nobody could believe we did it. But some of the recommendations are very much related to what we're talking about today. One of them is putting policy approach in place called extended producer responsibility, where the producers of products extend the responsibility throughout the life cycle of the product, not just sell it and walk away with the money. And that is for household hazardous products, which could include batteries and electronics and many of the green tech things that we use. We also have a recommendation on passing legislation on right to repair. There's been a big influx of tech that we can't even get a manual from the companies on how to repair them. They literally don't want us to. They want us to buy the next generation. That's too wasteful. It's got a huge greenhouse gas footprint. And quite frankly, people are frustrated. They pay a lot of money and they can't repair anything anymore. So that is one of the recommendations out of the commission. There are many more, but in case you have interest in following that, many of the recommendations we gave are becoming, they just were introduced on Friday last week into legislation. So it's very exciting to see the legislature take us seriously. Thank you. Next slide, please. And if any of you have ideas that you want the commission to take up, let me know. I've got a form you could fill out and help me get ideas run through the commission. Next, oh, you can go back. I think there was another slide. Yeah. So yeah, I guess I already talked about that, but you can see the commissioners there, including county supervisors, and it's a very, very good group. Next slide. So one of the recommendations was to ratify the Basel Convention. I don't know how many of you know what that is, but the Basel Convention is an international treaty it was first established to deal with electronic waste that was being sent to countries that could not handle it. And it was resulting in children, you know, and people in very crude conditions, very unsafe conditions, dealing with our waste. In fact, we found the state of California logo on computers and the sides of rivers in China. So we were part of the problem, clearly. Well, the Basel Convention hasn't been ratified by the United States. Pretty much every industrialized country in the world has ratified it except us. So what that means is we can still legally send electronics and now deemed hazardous plastic waste to other countries who simply can't manage it properly. They aren't resourced for it. In fact, I just heard yesterday that in Malaysia, they are getting over 350 containers a day of plastic waste from the United States. That is simply, they cannot handle that. And it's going to end up in the sea. It's going to end up all over the place and being open burned. So we have asked that our state ask the Biden administration to ratify the Basel Convention in the first 100 days and get us in line with the rest of the world on this treaty. So that because what's going to happen is our plastics and electronics can be literally caught out at sea right now if a country doesn't want to take it in, and they will just be floating around out there with no place to land. And they might have to repatriate. And it's just a big mess. Next slide, please. And it's ours to clean up. So we're a small but highly effective and highly high profile organization. I've been on NBC Nightly News talking about packaging, worked with Sam and Paul. We've done all kinds of stuff. In fact, Paul came with me when we were presenting to the PUC about this very issue of clean tech and what we're going to do with batteries and solar panels. We've got a long way to go, and we need everyone who's working in tech to help us truly green up the entire supply chain and create circular systems. So please feel free to join us, follow us, and we'll be happy to take questions at the end. So thank you for that. And I guess we can turn it over now to Paul Gao.
Great.
So, yeah,
Thank you, Eddie.
Quickly welcome Paul Gao. He's experienced in the industry with strong business development and being professionally skilled in IT/AD and e-waste recycling operations management and environmental compliance and remediation. And without further ado, Paul Gao, I'll let you take over.
Thank you. Let me share the screen. Oh, the host to a slide. Okay, sorry. So, good evening. My name is Paul Gao, and thank you for having me. And I also thank Heidi. I got the opportunity to work with Heidi and in the past 2 years. And she is a fighter, and she did a lot for recycling industry. So my name is Paul Gao, and I'm the founder and president of SEER. We are located at Mayfield, California. And we are our company started in 2000, and I'm just sorry, I don't see the slide, so I don't have to do the slide, correct, Thomas?
I can share slides. I can share your slides for you.
Let me see if I can pull up. We tested the slide. Hold on. I should be able to do that. Sorry about this. Where's my?
Whilst Paul was working on that, I'll just add real quickly that Paul is a real leader in electronics recycling. And
I don't know how.
he tries things with solar panels and vaping products, and he'll try anything to get to recycle higher levels of our electronic waste right here at Mather.
Tell you what, Paul, I'm going to share my screen, and you can just tell me when to go, okay?
Okay, thank you. I don't know why, but I have some problem to share my screen.
Oh, we've all been there this year, trust me.
I thought it was a new norm, but you know. But.
Yeah. All right, does everyone see it? You see it, Paul?
Yep.
All right, just tell me when to next slide, and I will click next slide.
Okay, you got it. Thank you. So the next slide, please. Yeah, okay. So our company started in 2000, and time flies. I'm still here to committed to providing responsible e-waste recycling in Sacramento. 10 years ago, we designed our processing plant and call our system Green Machine. And along the way, we did many improvements and added new features to maintain the technical advantage. And 3 years ago, we started actually vertically integrating our service to provide a whole IT asset management service. Next slide, please. So what we do here is, what we do for IT asset management. So we provide the logistics service, and we also do the data security. We provide a certified wiping and shredding service, on-site or off-site, plant-based. And we do also remarketing to harvest the components. And we do testing, repair, cleaning, repacking, redeployment, all the service. And by the end of the day, all the end-of-life electronics, we will actually recycle it. Next slide, please. So I want to talk about our green processing technology. So what we say our green machine is, we really use a very unique processing. It's a centrifugal force technology. So we spin the material just like at home you are a washing machine. So we spin the electronics, and then the physical collision of the material result in quick liberation and very clean commodity output. And our system process up to 15,000 tons of the electronic waste yearly, and we use 30% less energy compared to similar if we use the knife shredders to process. And next slide, please. So those are the electronic devices we all see, we are familiar with, from the computers, the IT equipment, the TV monitors, the tablets and cell phones, small consumer electronics. This is also included the vaping devices. I didn't put there, Heidi, but that's included in there. Next slide, please. So this is the finished product we produce. So you will see here is the residual materials here. So we have steel, aluminum, copper, circuit boards, plastics, and obviously plastic we call e-plastics. And Heidi talked about it's a big issue for our industry because the e-plastic, they have very many different kinds mixed together. So how to separate them? Do we have a solution locally, or we all now currently we ship to country like Malaysia for plastic recycling? So these are the topics we have to discuss. And the last picture is the batteries come out from the residual materials. Next slide, please. So here we talk about what do we do and what kind of electronic coming to our facility, and then what is going out from manufacturing process. Now we have many challenges, the challenges for the industry. So what it is the first thing is the increasing volume of battery. You saw the battery picture at the last picture, you saw at the last slide. So the increasing volume of the battery content in electronic devices, especially the lithium-ion batteries, those are difficult to identify, costly to remove, and also fire and explosion hazard. So the electronics, the second challenge is the electronic devices are getting smaller and lighter, such as like a vaping device. It's tiny. But so this will be less reclaimable material value, more plastic, more battery content, high percentage of the toxic substance like lead, mercury, cadmium, brominate from flame retardants. All those are high processing cost. Next slide, please. So we see the challenges. Also, this is opportunities for our e-waste industry. So that's what our business plan is. So that's why in the very beginning, I said we are vertically integrating our processing. So we want to be one-stop shop for the product reuse, refurbishing, and recycling, and also collaborating with the manufacturers to provide the recyclability data. So we had a meeting with some of the OEMs, with their designers. So we told them this material is difficult to recycle. And this material, if you put a plastic tape on that, it's hard to separate. It's difficult to machine to process it. So the customer also demand for more environment sustainability solutions. So a few years ago, they would just say, can you recycle those electronics? But now they demand more, say, can you reuse them? Can you harvest the parts? And then how you can actually turn the plastic to a new product. So I think this is a trend for a circular economy to capture the new value from the retired asset with some standards. So we are working with plastic recyclers. and they try to have some of the standard. And I think UL or TÜV, they are now coming some of the recycled plastic standard. I think this is a great thing. This is the recycling industry and the OEMs and also the standards to work together. So that way it's from the designing to sourcing to manufacturing and to reuse, recycling. And then this is a true, I think, circular economy. Next slide, please. Great. So I would just talk about the recycling industry opportunities. Now I want to talk about the green waste from the clean technology. So we always thinking about this clean technology. I think the clean technology will create the green waste. So normally we're thinking about this we're thinking about, oh, okay, green energy. And then we will say PV and the EV. So the solar panels and the electric vehicles. So the PVs, I'm not going to say anything because Sam is the expert, and he is going to talk about it. But I want to talk about the EV battery recycling. So we are also research on that subject. So we project tens of millions of new EVs all sold between now to 2025. And that means tens of millions of battery will need dependable recycling solutions. And the demand for cobalt, lithium, other raw material is really high. And this now becomes a strategic material. So, and also if you see the chart, you can check the chart here, you can see California is really, we are the leader in this EV car market. So that is important for us to have a solution for the batteries. Next slide, please. So we have this CleanStart here. So I think this CleanStart connects all the California region CleanTech community. This is a great thing. I think building a CleanTech industry should include the green waste recycling. This is really, we can achieve the cradle to cradle circular economy. And at the last, I think I want to thank Thomas and the CleanStart, the platform. So we have the opportunity here to talk about this thing. I think we can talk a lot. We can talk the whole night. I just don't have the time to do that. So I hope, after the meeting, please, any questions, email me, and so we can chat further. And thank you so much. And the next slide has my email address.
We'll make sure to put that email address in the chat for people that want to be able to connect with you.
Thank you.
And with that, I would like to welcome Sam Vanderhoof, CEO of Recycle PV Solar. One thing Paul had mentioned was, connecting the community of technical startups and everything with the recycling and the circular economy and bringing it all together, and actually doing kind of a bigger event on, recycling clean tech. I think the bug was put in my ear a long time ago with about like, hey, why aren't you guys talking about this? I know Shira Lane has probably wrapped my knuckles 1,000 times on it. But we at CleanStart, we also put on events where I get a lot of help putting on events. I want to say from Soraya Jackson here, who's helping me with this, but we put on events like green drinks and our CleanStart perspectives. And Sam presented at one of our CleanStart or one of our green drinks. And it was like, why it was really like, we need to talk more about this, and we need to have a kind of a month or a period where we're talking more about the circular economy and the waste created from that. So like I mentioned later in March, we will have Shira Lane talk about the circular economy. But right now, I want to welcome Sam Vanderhoof of Recycle PV Solar. And I'm going to start sharing his slides for him here in a second and let him take over.
Are you ready?
Let me just about there.
Okay.
Always one more step. Everyone see it? Everyone good?
Got it. Great. Thanks, everybody. Thanks for having me. My name is Sam Vanderhoof. I'm CEO of Recycle PV Solar. And our main goal in what we do is to focus on the recycling and proper handling and even repurposing of solar PV modules. That's basically all we do. We don't do electronics or anything else, except when it's in conjunction with the PV solar system, like inverters and things like that. Next. We also partner with a company that's in Europe called PV Cycle, and they're our mentor, but also our partner here in the US. PV Cycle has been doing solar recycling, PV recycling for more than 13 years now. And they're a nonprofit that has put together the programs and policies throughout Europe to be able to do it in a collective way in cooperation with stakeholders and the PV industry to bring down the costs and to facilitate the collection and proper handling of PV throughout Europe, and now expanding into the US with our partnership. Next slide. So our mission is pretty straightforward. We just want to keep solar materials out of the landfills and to take all these materials and reuse them in the best way we know how to. So we've been doing this for we started really about 4 years ago in the beginning, but formally a little more than 2 years ago, started officially in Tucson, Arizona. We tried to do some recycling in California, but the DTSC regulations were a little too stringent for us at the time. And in order to get started, we moved our facilities into Tucson, and then more recently, we're opening a new plant in Reno, Sparks, Nevada. Next. So I have a long history in doing solar, and I'm part of the problem. For many years, I manufactured PV solar panels and systems and sold them, and so a lot of the systems that are out there, especially ones you see around Sacramento, we manufactured a lot of the components for the systems in Sacramento, the PV Pioneer 1 and 2 systems. There's more than 9,000 systems we're involved with in Sacramento. So a lot of those panels you still see today are part of what we're involved with. And now those systems they're aged. A lot of the systems are 15 to 18 years old, and it's time that they are looking at end of life. We celebrated just a few months ago, California having over 1 million homes now solar powered in California, 1 million homes, and that's growing. And it's growing by 15 to 30% per year. It's not a small task to install these systems, but there is an end of life to all products, including solar. Next slide. So I'm going to go through some of the issues and the problems we see, and then offer some solutions as well. So we see that there is a rapid increase. Even during this last year in COVID, the solar industry increased business, increased installations, I think about 22%, even during the crisis of COVID, and it's not slowing down. It's a clean energy source when it's installed and managed right. But one of the concerns is there's no national programs for recycling at end of life. And there's very few government programs today that encourage that. So we spent a lot of time working on policy throughout the US, trying to encourage stakeholders to engage in new policies that encourage end-of-life proper handling. And I'll bring this up a couple times, but our partners in Europe have been instrumental in creating the mechanism for 95% of all solar that's decommissioned in Europe is now recycled and handled properly. But in the US, it's less than 10%. So we have a long ways to go. Next slide. So just to bring it in perspective a little bit, most of the solar panels that are coming into the US come from abroad. They come from Asia, some from Europe. There are a few manufacturers in the US, but not that many. But 140,000 panels, and increasing every day, they're being installed. 140,000 panels per day, 7 million pounds of panels every day. It's a huge problem. It's a huge problem if you don't have plans in place to be able to handle those when they're decommissioned. And we'll talk more about why things fail and why modules don't always last as long as we think they should. Next slide. So again, some of the problems that we're seeing. This is a pile of panels that you can see, laminates, that these are in the US today, and most distributors and warehouses across the US have piles of panels, much like this or much worse. The infrastructure needs to happen in the US like it happened in Europe, and we can follow some of the same guidelines that Europe has done. Again, we're only doing 10%, and they could do 95% in Europe. We can follow some of those practices that made that happen. Next slide. So one of the reality checks that I think that being in the industry for as long as I have, almost 40 years, that solar's sold on the premise that it lasts for a long, long time, kind of forever, and needs little or no maintenance. Well, that's a great selling point, but the reality is a little bit different. So we're seeing a lot of defects from installations, recalls, damages just in the transportation, trucking. In California alone, we did a study last year, about 2,000 to 3,000 solar panels per month are damaged just in transit in California alone. So we're seeing, a big issue with solar panels, even though they do last well when they're out and installed, if nothing damages them. We're seeing severe weather problems being a big problem with climate change. More and more systems, like you see, the problems in Texas with weather and ice storms. Solar panels are being damaged on a regular basis. Next slide. So here's the growth of solar. If you look at it, it's not slowing down. It's one of the largest employers in the US right now, and in growing on a regular basis, because it does provide good jobs. It's clean energy. Groups that former employees that were in the coal industries are switching over to cleaner energy technologies like wind and solar, and it provides quite a few jobs, and higher paying jobs usually. Next slide. So one of the things that it was hard for us to really understand, being in the industry for so long, is why are these solar panels coming down? Why are they being decommissioned? It's not always because they are broken, but some of the causes, or the biggest problem is weather damage. We're seeing so much weather damage. We worked on a project last year in Texas that was 60 megawatts, and it was damaged by one hailstorm. Came through and smashed the whole system, or most of the system, in a matter of 15 minutes. The system was destroyed. And the problem is that the insurance companies are paying huge sums now to the payoff of that project was more than $70 million out of pocket for the insurance company. So that is all being relooked at. We're working with insurance companies now to mitigate some of those costs for decommissioning those systems after and clean up after they're damaged. The other problem is that we're seeing is in the permitting and bonding, that when these systems are damaged or they're abandoned for whatever reason, that the local jurisdiction, the cities and city planners aren't stuck with a bunch of solar panels that are abandoned because they have little or no value, or the cost to reclaim the solar panels are quite high. So bonding is now just beginning to be required across the US, which is adding cost to the systems. Next. Again, this is just talks a little bit about the failures. There's more failures than we realized for a lot of reasons. And again, weather is a big part of that. As temperatures get hotter, the solar panels are made with components that heat up in the sun. They're made to be in the sun. Some of the worst conditions, anywhere, because they're made to be placed in the hottest places, and backskin failures, delamination, these type of things are happening not in 25 years, but what we're seeing is 7 to 12 years. And yes, a lot of these systems or solar panels have a 25-year warranty life, but the problem is the companies that built these are usually going out of business within that 7 to 12-year period. So there's no warranty mechanism at the end of that shorter period to handle the cleanup. Next. Here's just a quick snapshot. Today, a lot of the solar panels are being reused, a high percentage, a little less than half of them. This is just in the US, and they're being resold or reused for off-grid systems especially. But that number is really starting to go down because the price of new panels are so much lower, and the cost of shipping is so much higher. So what we're seeing is more and more systems are not being used. So that number is scaling down. Most solar panels are going to landfills, and that's a tragedy because there are a lot of materials in those solar panels that can be recaptured. Next slide. This just shows some of the places that U.S. waste can go to. I mean, it can go to, I think Heidi talked about it, and I've been to these places, really, really desperate countries that have little or no environmental regulations that stop our waste from going to those countries. And that's one place they can go. They can also go, they can be reused and refurbish the panels, and they could be used for a lot of off-grid systems in Africa, Haiti, Mexico, a lot of other places like that. So those are good places for it, or they can be recycled. It's our choice. Next slide. You can just go through a couple of these slides. It just shows some of the damage that we're seeing on a regular basis. The floating system, solar panels are, wind has pulled these systems up. Next slide. This is more of a local one here. Some of these systems have been burnt up. So the solution, I mean, there are solutions, and other industries, Paul had talked about it a little bit, and Heidi's real involved with components that need to be collected in a proper way and handled in a proper way, and then sorted and then repaired when possible, and then put back into the field if they can be. Otherwise, recycling is kind of the last effort that happens, and being able to do that in a responsible way, but also in a cost-effective way. And that's one of the challenges we have today, is that if we as a nation and an industry, a solar industry, if we can pull the solar panels together, that volume, and make the policies happen, then we have enough volume to build the plants to do it economically. The problem is we don't today, because the landfill is basically our competition. Next slide. So here's one of the ideas that we see that could work for handling end-of-life solar. So you guys, everybody knows that when you go to buy a new consumer product of different types, and there's a whole host of them. This is a short list, but refrigerators, TVs, most of these consumer electronics and components or products have a limited lifespan, and at that lifespan, they're difficult to recycle. So the fees that we pay up front, usually the end user, that helps subsidize, being able to responsibly handle these. It's just interesting that solar, being sold as green, has no programs, and the cost for today for recycling solar panels in the U.S. is quite high. We're talking about $15 to $25 per panel in the U.S., where it really could be subsidized, we think, for $2 to $4, and we can make that happen in a short period of time. Next. I think if you hit it one more time, there we go. So this is what we're kind of facing. We're facing in the U.S., $15 to even $45. $25 is kind of the average, but we're seeing it as high as $45 in some states to recycle a solar panel in the U.S. They have it down to 90 cents in Europe. They've been doing it for a while. All we have to do is copy some of the processes and procedures that work there and bring that same technology here to the U.S. And we already are buying machines from Europe to do that, to bring them here. We do have challenges. We have the challenges of the U.S. is quite large, and the transportation costs are quite high. So we're still working on that. Next slide. Here's some of the components we pull out. Glass, and I think Heidi talked about glass and recycling of glass in Sacramento. That would be great. The cost of transporting glass is very high. So, and the recovered material, the recycled glass that we remove has a very low value. So, for instance, a ton of glass is worth maybe $80 to $100. That's on the high side, but it costs about $80 to $100 to ship it, even a short distance. So, you try to zero out the glass, recycled glass is difficult. There are other materials that we can make some money off of, but today, because of the volume we have today that we actually can collect, the profit is very, very low. Next. One of the good things that we're seeing is the potential in the US, because there is the volume here. If we have the policies in place to gather those materials, those panels that are being decommissioned, and keeping them out of the landfill and trying to compete with landfill prices, that you can see here the amount of recovery between now and 2050 can be quite good. And also the being able to replace those materials back into the field. Silicon, silver, copper, all these materials do have a value, but they are very difficult to extract from a PV solar panel. Next. Yep, I forgot this would come up like that. Here we go. So here's some of the things we've been working on. Some of the machines we've been working on in Europe, trying to bring some of these machines. We have parts of these machines already here. We've imported them into the States, and we're using them now, just getting them set up in Reno. This yellow one on the right is a complete machine that you throw the solar panel in the front, and it separates all the materials into its components very cleanly, and it does it fairly efficiently. It's a little bit slow. It takes about 1 minute per panel, and we'd like to see that about 3 times faster. These machines are really expensive, and in order to make them cost effective, we've got to run them 24 hours a day, and we have to have the feedstock. And right now we can't get enough feedstock in one spot to justify it. Next. Reusing solar panels is something that we try to do whenever we can. We donate a lot of solar panels to Native American foundations and tribes and reservations, mainly for off-grid. But there will be a point when there's too many of those to go through. So being able to find new homes for reuse panels to reuse those is definitely a challenge. And it needs a whole support mechanism. It needs to have training put in place so that there are workers that can go out there and install these panels properly. Next. So one of our mottos, don't let solar go to waste. So being able to reuse these solar panels or to take the components and remanufacture solar panels is what we're doing today, and it's our goal. And it's something that is something we're working on a regular basis, along with policy in the US to make that happen. Next. Here's my contact stuff. So please contact us if you have any questions. We're also looking for employees. So whenever you come across somebody that wants to jump into this industry, please put the word out. Thank you.
Send us
Thanks
the
very
job
much, Sam.
posting, Sam.
Definitely send some job postings your way
Yeah.
there.
We need help. We need help.
Yeah, this is the right place.
All right, so I'm going to welcome everyone back to the panel here, and I'm going to add them to also the spotlight with Gary Simon, the founder of CleanStart. And for those of you who have been here before, you can put your questions in the chat or raise your hand.
Yeah, let me just stay on this topic of employees. Sam, how many employees do you have now working?
Mostly we have contract labor, 1099s, and we have them scattered throughout the western states and a little bit in the eastern states. So we have about a dozen folks right now.
And Paul, how many do you have?
So we have about like 80 employees.
Oh,
So we use probably, we say 80 green jobs, and then we have probably 60 is our permanent employee, then 15 to 20 is the temp agency or temp employee.
well, that's significant. And obviously this is an industry that is still growing, but we're sensitive always to, where are the job opportunities? And this doesn't sound like highly skilled labor. So what kind of employees do you have? Is this people that have engineering degrees, or is it high school graduates? Who works in this kind of industry?
So actually, the demanufacture work. So we did, the California has a program, SB 2050, for recycling the old TVs or LCDs. And those demanufacture workers probably are lower skill workers. But now things are changing. So like I said, 3 years ago, this is changing to you have to be a one-stop shopping for the consumers or customers. So we do more of reuse, refurbish. So we have the engineer degrees, we have IT technicians, and some of it with associate degrees, some are with like bachelor degree. And we have one very skilled IT technician is from Zoom. So it is changing. And also I think, in our industry for e-waste recycling, really you want to grow is you will have to incorporate AI technology, industry collaboration. Those will be the future. So in this aspect, I think, Sam, if you have the sophisticated machine to recycle the solar panels or PVs, you need an engineering degree to operate that. It's not like just simply take them apart. So we do have mechanics here because we have all the machineries, computers, and the data. So that's what it is.
Yeah.
I think.
And that's a good point. I mean, one of the things we're looking at right now, we've applied for a grant, and part of that is AI to be able to identify the solar panels that are coming in and categorize those. There's nobody in the US right now that is looking at when solar panels come in from the field, what happened to them, what's wrong with them, and how can we make better solar panels in the future by collaborating with manufacturers, and also look at how can we recycle better those materials. There is no connection right now.
Can I add to that, Sam?
Sure.
because I have to get off to this other event, but I did want to say that that's really the point of what our organization does, is we find problems, problem waste streams. We go upstream to the manufacturer. We say, hey, we need your help fixing this problem. And then if they're willing to work with us, we're all about it. And we try to partner, go through pilots, figure it out, whatever. When they say there's no problem, you're a solution in search of a problem, then sometimes we end up in a battle and have to go legislative route and do mandates. But this solar industry actually understands they've got a problem, and they've been talking with us for a couple of years. We passed a bill to declassify them to universal waste from hazardous waste. Paul has been a big help on that. But the problem is we don't have, the finances are not there yet because landfilling is too cheap to drive them to Sam and to Paul. And so we have to get companies to pay the little extra, or we need them to do what they do in Europe, which is you don't sell it unless it's got a closed loop system, and that's all built into the product price. And so at the end of life, when people have they see no value in it to them anymore, they illegally dump it, they turn it into a fence. I've seen it. They've smashed them with sledgehammers and put them in the trash can. I've seen that too, because they don't know what to do, and they're not going to pay hazardous waste prices to haul it away. So we have to make it simple, easy, and free at end of life for people to do the right thing. And until that happens, we're going to have a lot of improperly handled stuff. And it's sad because these are materials we really need to get back for the next generation of products. So if anybody would like to help us with this, let us know. I got to get off, and Jordan's going to stay on to answer questions along with everyone else. So.
All right. Well, thanks for your time, Heidi. It was very
that
good.
was
Heidi.
fun.
Yeah. Good to see you.
Good
Thank
to
you.
see you too. Talk to you soon.
All righty.
Thank you, Heidi.
Oh, good to see you.
Thank you,
guys.
Heidi.
Looks like we're
So-
getting a lot of hands up on questions, but Gary's going to be managing it. So take it away.
Well, I could always use help, but I got to go back to Paul on what you've been doing. You were talking about, I think, 15,000 tons of waste a year. Well, what percentage of that is all the electronic waste you think is in this country? What's the scale like for what you're doing versus the scale of the problem?
I think we are one of the largest e-waste recyclers in the Northern California, and I think, well, it's a huge issue, and you know, I think in California we have probably 4 or 5 of the e-waste recycling companies, and some of them may have the similar volume we do, but we have been processed about 10,000 tons e-waste for the last maybe 10 years, and we have seen the volume drop, but it's not really drop. Is because less electronics, is the electronics become smaller or lighter. But the piece-wise, we have a lot. So it's just a, you know, we don't really give a measurement on piece count because it's, you know, like a cord or a small iPhone, you know. iPhone, we actually, obviously, we do the serial numbers, we count that, but it's not every piece we count. So it's difficult to give this measurement, say what kind of we do in a country.
Right. And we've got a question here from Emmy Stenstedt to Sam. What's your big yellow box cost? What kind of cost are we talking about here?
Plus shipping, about $1.5 million.
So we're not going to put one in every community at that price.
Yeah, by the time it's all set up, it's about $5 million. By the time it's set up with the building and all the infrastructure needed to support it, forklifts and all that, about $5 million.
And
so, but
how many panels does that serve?
It does about a panel a minute. And what we're trying to do is we're working with an Italian company we're trying to at least double that, if not triple that throughput by doing some pre-sorting up front. So, but the problem is not that
is you're going to need multiple of those boxes at a scale installation.
Well, the yellow box in particular, we've been working on the design of it so it's mobile, so we can actually do staging places around the US, and it can be taken by a truck locally and then used on site. So that's the idea for the yellow one. So we'd have
All right,
one machine on the West Coast, one machine on the East Coast, and staging centers.
cool. All
Yeah.
right, thank you.
Yeah.
Cynthia Lung, you have a question?
You ready?
Thought she was on.
She just froze. Oh no, she's there. Cynthia?
Oh, I hope my internet did not just reset, by the way. A
Oh,
white paper on this, and I was really curious. Oh, am I frozen?
You're good now.
I'm good now. Okay, great. I don't know how much you caught of that, but basically I was taking life cycle analysis, and our white paper was on PV recycling. So a lot of the arena reports that came up were like top of mind. And we're talking about ways to figure out like policy with this, because as you said, it's very expensive to recycle at this point, and they're incentivized to salvage materials. I guess I'm curious, in addition to SIA's efforts, what other pushes on the policy side are there? Because one of the things we analyzed was like having mandates that actually like made these requirements would at least push some of this, at least in terms of getting this started. Because as we've seen from all your graphs today, like the curve is coming, like all the materials are coming. So I'm curious about your thoughts there.
Okay. Well, I'll just throw this out. The curve is coming, but take a guess on what in 2020, last year, what was the built up decommission panel in a number of watts or megawatts or gigawatts? Take a guess.
Was that, well, I don't know if it's a guess, but it's like 90,000 megawatts. It's from the report that I was looking at. Is that?
Yeah, no, not even
Right.
close. Not even close. It was 1 gigawatt last year, a gigawatt. So the number is already here, and that's one of the issues. I mean, I've been doing this for a long time. I'm just shocked at the numbers I see, and we work with the folks that put together the IRENA report, so we know it pretty well, and we're helping them on a new report. The report is probably off by quite a bit, because the IRENA report did not include any weather-related damage. So that's a 30 or 40% adder on top of the ARENA numbers. So the problem is here today, and that's one of the issues. We're seeing it today, and there's no solutions today. And that's some of the frustrations we see, that the policies need to happen a lot quicker. And also, in order to do and copy what they did in Europe, they engaged it. The stakeholders and the manufacturers engaged it and made it happen. They were forced to do it. It wasn't a volunteer program, just to make it all clear. In the US, it's volunteer, and it makes it really tough when it's a volunteer program. If in order to get to where we're at today, where solar panels cost around $20 to recycle, and they're only less than $1 in Europe, how do we get there when landfill's $1? It's until we can compete with the landfill costs. It's going to be a real challenge.
Are the panels in Europe a lot more expensive because they're recyclable, or is the cost approximately the same?
No, they add 90 cents to the cost. It's almost nothing. It's because it's organized, and it's forced. I mean, it's part of the WEEE directive that they have to recycle all products in Europe, and not just solar. So it's made it large enough, and it's made it organized enough that it adds 90 cents to us, or less, 70 cents, and I hear it's going down even more so, per solar panel. It's almost not seen. But just like when you go in and you have your tires changed on your car, there's a little fee down there. It's $2 a tire or something. You don't notice it, but that really supports the whole background of taking those tires and putting them in the right places so they don't end up out in the desert someplace.
Yeah, piles and piles of them.
Yep.
That you run into still every once in a while.
Even still, yeah. But I mean, the thing is that solar is sold as such a green, clean energy, and
Yeah.
it is all the way through its life cycle, and I think one of the problems that we're seeing is that as an industry, and I'm part of that industry, I've done it for a long time, that this 30-year life with no maintenance is not really true. And we're seeing 7 to 12-year decommissioning. That's really different than kind of 30 years. It's not the same. And it's for a lot of reasons. It's not just one reason. I mean, it's tax credits and weather and a whost of problems. But the reality is a gigawatt coming down last year and probably 1.3 gigawatts in 2020 being
It's a lot. Yeah,
and we think, I mean, from Irina, we're talking to the NREL about it. We think about the year 2030 or 2032, somewhere in there, there'll be more solar panels decommissioned than will be installed. So who's gonna deinstall all these panels? Where's the labor force gonna come from? And that's not very far away. It's 10 years from now. Who's gonna deinstall all of these when the labor force has to be twice what it is today that are installing these? So we have some challenges.
All right, so Kevin Logue, you got a question about locating old solar panels for a project in Haiti. Do you want to ask your question?
Yeah, thank you. So we have a company that has already deployed down in Haiti, and we are looking for modules that are still, not completely broken and still operating, because they'll take anything down there right now to have lights. So for us, we see that angle. Now we're working on a project right now where we're decommissioning a 1 megawatt project here in Northern California, then rebuilding a new 1 megawatt project on top of it. And those modules will go straight to Haiti. So if anyone does have a need or want a place where there's to go, that we are an outlet for that.
So Sam, in your experience, from what you've been collecting, how many of the panels, percentage wise, are eligible for reuse, refurbishment, and can go out, or is that number not very well known yet?
Well, it's kind of known. Somewhere around 30%. It can be higher, 40%, 45%. But there's a challenge in all that. I mean, there's several challenges, and it's one of the things that face us. We've got the recycling process down pretty well.
Right.
We know how to do it. We know the equipment. We have the technology. The other part of it is tougher, because as prices drop for new solar panels, and the perception is
Sure,
you can buy a new solar panel today for about 35 to 45 cents a watt.
yeah,
Easily.
just incredible.
Yeah, it's amazing. It's amazing.
Yeah.
And you have to ship that panel from someplace to get it to where you are. Now, a used panel has way less value. It has maybe, if it's a good panel, somewhere in the maybe 7 to 10 cents, maybe value per watt. And then you still have to ship it.
Yeah, right.
And that is the shipping costs, really, that all this logistics. We hired a logistics person just to handle that, because the shipping costs are killing us. So when you ship it twice, if you bring the used solar panel in, and you test it, fix it, certify it, send it back out, you've got 2 shippings right there.
Right.
And that shipping cost could easily cost a penny a watt, up to 2 cents a watt, just to do that handling. So that's always a challenge. And then being able to have the right people in place, like in Haiti, to be able to reinstall those and do it in the proper way. What we have seen, and we're cautious about it, is we see our garbage going to developing countries and not being handled right when they land there, and end up in their landfills, or even worse. So.
Yeah, well, what that says is it kind of goes the way of we used to collect and refill Coke bottles, but it was just cheaper to meld them down and start with a new bottle. It sounds like that's the direction this is going to go eventually. So
Eventually, we're not there yet. I mean, we're still. I mean, there's enough value in these, and they still create kilowatt hours, and there's still a need. Mainly off grid is a big part of that in developing countries. So it's that whole infrastructure. We've partnered with a company that does training and installation of remote systems to be able to do and help with that.
interesting
It
perspective.
It's not free. I mean, if you have these
Right.
panels, so you need panels, then you need the racking to go with it. Then you need the electronics to go with that, and the batteries or inverters or controllers. So it's the panels are just one piece of the puzzle. But
Yeah,
it's
and
something we
increasingly
definitely support.
A
Absolutely.
small part of the whole puzzle. Daniel Clark, you're next up. What you have a question?
I sure do. Thanks for getting on again, Sam. I saw you last time, and sounds like you have a very clear picture on everything that needs to be done to make this something that can be great in the future. My question is, what's the reusability of your glass? I don't know if you remember, we talked about us making our 3D solar cells from that recycled glass. And I was curious, is there like a reusability rate when you recycle it of stuff that's good and can be reused and stuff that cannot?
For sure. And that's what we're working on, some newer machines. We're working with 2 companies right now. We're testing new ways of processing the glass. Remember, the glass is 70% of the weight of a solar panel, so it's a huge amount. To be able to get that glass off efficiently and cleanly is definitely a challenge. And where can it go? Depending if it's filled with any contaminants. And remember, a solar cell is kind of glass, so you get the solar cell mixed in with the glass, and then that clean glass isn't clean anymore. So it's really a challenge to separate that. So we have these 2 tests we're doing right now. Is really interesting. We'll see how they come out, but the volumes that this new process can do is amazing, just amazing, and hopefully super clean. That's what we're hoping for.
And my last question, I don't think I got answered from the email. So we have an innovative German company that can rework that glass and turn it into a resin where we can cryogenically mold it into these micro solar cells. And you can't make these micro solar cells with a 20 micron cell wall thickness with conventional injection molding. We're talking about glass that's flexible. This is a next generation 3D solar modules. And so if you had the ability to get us that mesh size, we could determine with the German company if they can, turn that waste. I mean, it's kind of like waste what you have because you can't ship it, right? So we potentially have a way to turn that into recycled micro 3D solar cells, but we would need to kind of get a sample or figure out the mesh size.
We're working, and I wish, let's talk about it offline, but we're working on the mesh size of all our components right now for a lot of reasons. So
okay, thanks. I just it makes me look bad with the German company when they tell me to get someone on there and then they don't answer back. So thanks.
Okay.
All right, let's go on. Paul, question on the batteries that you're extracting from electronic waste right now. Are you yourself able to recycle those? Do you have to send them someplace else, or are they just piling up somewhere? I have worked with a company called Big Battery in the Midwest that was attempting to be in the lithium ion battery recycling business, but I don't know how they're doing currently. What insights do you have on that?
So the lithium ion battery is, we don't recycle the batteries. What we do is we separate the different chemistry, we separate them, and then we take them because the US DOT regulation has a requirement how to shipping those batteries. So those batteries now ship to battery recyclers for reclaimed lithium, the cobalt, those materials. And this lithium ion battery field, I think there are 2 companies now is a leader. I think one is in Canada called Lee Cycle, which is they use a method to separate, separated the lithium, the cobalt, and become a powder and can be reused in a new battery solution. And there is another company in Reno called Redwood Materials, which is founded by a Tesla co-founder. So I met him, I think last year to discuss it. I think his idea is he built small size refinery operations because the battery transportation is not that much compared to the solar panels, but still a challenge because you have to tape them. It's fire hazard, it's explosion issue. So he wants to build those modular refining facilities to extract the lithium. And I think Amazon just invested in that business too.
Oh, really? Well, that would be a new development. And the company in Reno, is that JB Straubel's company, the redwood materials?
Yes, correct. Yeah. Yes.
Yeah. So what's Amazon trying to do here in the recycling?
So Amazon, I think, well, Amazon is everywhere because we use everything is Amazon. So Amazon is, I think, for their sustainability, and they have many of the data centers, just like Microsoft, like 3 million supercomputers or servers. All those computers, you know, we need a solution for that. So like Microsoft built those called a circular place. So they are doing that is to reuse those servers. But whatever the service we're using, you have the backup units, you have the battery, you have all those issues. I think that's what Amazon is after. And also we are using millions of those rings and the those rings or the candles and those things, they all have lithium battery in them. That's what I think they are looking for a solution. So this redwood material is specialized in lithium recycling, lithium battery recycling. So they are in Reno, so next to Tesla. So obviously they have the feedstock from Tesla, from the Panasonic battery operations. That's what I think those are. I think it's the two leaders. I know there is another one in Europe, but those are in North America, they are the leaders.
Yeah, very good. All right, other questions that are out there. I guess Venkataraman is left. Let's see who else is up here. Are there any more hands up, Soraya?
No.
All right. Well, then turning to Jordan and sort of continuing the conversation. Obviously, it looks like we do need more rules to determine product content, product design to increase recyclability. Where's the Recycling Commission on that now? Where in what stage of the process are you looking at focusing on e-waste and solar PV waste?
Jordan, Amon, do you want me to answer that since it's about the commission?
Yeah.
Okay, I'm on the commission and I can tell you that as chair, I think that where we are is if somebody submits, you know, we were tasked with trying to achieve the existing recycling goals, and unfortunately hazardous waste does not fit into the recycling goals. We were also though tasked with meeting market development goals and meeting greenhouse gas goals. So no matter which way you cut it, we can pretty much tackle something.
Right.
But the number one issue for the haulers was dealing with contamination in their loads that is costing them a fortune to sort out and finding markets for the stuff they collect already.
Mm-hmm.
So we kind of tackled that first. So now we're getting into the harder stuff. And I personally would love to see a proposal on solar panels. In fact, if I've got the form, and if Sam, you and Paul want to work with me on completing the form for the commission, I could, as the commissioner, introduce it to the Market Development Committee and then, or into the EPR two-person committee I'm on, and then we could take it through the process through the commission and see if we can get a 17-0 consensus support for that proposal. I do think it's time, and I think people understand that we're out of time. I mean, we've been seeing truckloads of solar panels coming into the landfills for more than 5 years, and then telling people we can't take it here, and you have to call a hazardous waste truck, which could be $5,000, and I'm not exaggerating, to take it. And they are so upset. They are crying. They are furious. They feel duped. Now what we're getting is we're getting people that put them on their roof years ago or bought a house with solar panels on them that fail. They don't want them anymore. They don't want new ones up, or whatever, find out they're hazardous. And then they're in, one question I had from an agent, real estate agent, was, when are you guys going to start telling the world that this is hazardous material on the roof? And why isn't this being disclosed to the new owners as hazardous material? Now, you can think about the market impacts. If the agents, the realtors start taking this on as hazardous product, that should be in the disclosure. Nobody's going to want to touch them. And that's not going to be good for solar. And we need
Not
it.
at all.
So these are the kinds of problems we're starting to have. And I mean, Sam's had the calls, frustrated homeowners, absolutely furious. They're getting this kind of thing from every agency. Go over here, go over there. Nobody's got an answer for them. So I just think if the industry doesn't lead on this very quickly, it's going to be a mandate that comes down from somewhere. But the good news is I think the Biden administration is going to start taking this up as part of their Build Back Better program. And we should be pushing and maybe sending joint letter. Maybe it could come from CleanTech and a bunch of us could sign on saying, hey, Biden administration, you're going to go push for clean energy and build it back better. Let's make sure we can close the loop and have a circular economy on these things. And let's make sure that the federal agencies have money for grants to actually build out the recycling system for these panels in the nation.
Desperately needed. And the disparity between the numbers we've heard tonight on what the costs are like, what the problem is like in the US versus Europe is pretty stark. So clearly there's opportunity for doing better.
Yep. And then Paul and Sam and all of you, I'd be happy to work on a letter like that, just a simple sign-on letter saying we got a problem, we need it solved, and we need to put it into the queue now as they're starting to develop the programs they're going to roll out.
Sure. Yeah, Heidi. So actually, we got many calls, and now because the solar panel is like e-waste, so all our customers are calling us saying, "Can you take the solar panel now? Because those are the universal waste now." So we, but like Sam said, the DTSC, the California regulation, we just, it's a lot of work, in the pipeline. So we agreed to actually doing some of the testing project with Cal Recycle and the CPSC, Butte County. So we are going to do testing in our system or in our machine. And because we have a very unique machine, so we can spin the material and with high speed. And that way, hope we can test to see if we can separate the silica and the glass. Sam, so that's what we are going to test to see if it works.
Let me know if you need panels.
Yeah, there you go. Well, I think we formed up a team right here. But let me thank all of our panelists tonight. We'll turn back to Thomas in a minute, but round of applause for this panel. I mean, outstanding.
Thanks,
So much good information in here and lots of opportunities for future improvement. So really glad all of you could join us for this discussion. It doesn't sound like it's going to be the last one we have on the topic, but it was pretty intensive. So a lot of good information came out of it. Thomas?
All right. I want to give some additional thanks to our program sponsors, Hacker Lab, Momentum, GT Law, and Reverent, and our community partners that help us build this clean tech community in the greater Sacramento area. And I want to thank everyone for attending. I'll be editing this video down and sharing it out later. Look forward to joining some other CleanStart perspectives and clean tech meetups, including another one on the circular economy later this month at 9 a.m. with Shira Lane. And with that, I'm going to end the recordings, everything, and thank you everyone for coming.
Thank you, Thomas.
Thank you.
Organized. Great job. Go Heidi.
Yeah.
Thanks again, Thomas.